Hello, everybody. My name is Christian Hüttich from University of Würzburg, and I'm first of all thank you, Erwin, for making this possible to present our topic within this session. So I will use the next 10 minutes to introduce you to our activity on building a science network for standardized and continuous in-situ data for crop monitoring within the DEMMIN experimental field. So first the question, why is it important to have continuous data available for crop monitoring? First, there is a disbalance. There's disbalance, as this graph shows here, between in situ data acquisition, coordinated activities, and satellite data flows. So I think you all know that the analysis-ready data landscape on the world is very well established. But what about analysis-ready data and continuous data within the in-situ data network? And JCAM within the GeoGlam community just raises these questions and is doing that within the JCAM experiment, focusing on winter wheat, test sites covered around the world, and a specific guideline for data acquisition and processing on specific key soil and vegetation parameters. So often we have the focus on satellite engineering, data management, and data generation of services, and there is a need for integration and coordination of existing in situ networks for large-scale CalVal activities and EO programs. There's also the need for integrated and multidisciplinary partnerships to foster open data policy, which is also key that different international partners can share their in situ databases and provide data access. So we are realizing this, or we are part of the JCAM experiment with the DEMMIN experimental site, which is the so-called durable environmental multidisciplinary monitoring information network, which is located in northern Germany, and it's highly cultivated with winter wheat, barley, rye, covering almost 60% of the fields, and around 13% is covered by sweet corn, sugar beets, and potatoes. So there's a kind of a variety between crop types, but the main crop type is mostly winter wheat. Here you see the distribution of the ground stations. They are maintained by big research organizations in Germany, like GFZ and DLR, but also the DWD weather service is active there. So we have key climate parameters and soil parameters covered. Soil moisture is covered with a soil moisture network. And it's also integrated in a German network of in situ and ground measurement activities called Terreno. So it's basically a test field for validation and calibration of remote sensing data. And the goal is method development, remote sensing data, validation, and transfer of knowledge. Our aim is to create an infrastructure and cross-university platform for generating secure, tested, and freely available research data. To realize this and to make this happen, we need a strong collaboration of all kinds of partners, like big university research organizations, Helmholtz, GFZ, DLR, and also university activities. So as said, so we are part of the JCAM joint experiment for crop assessment and monitoring, which is just looking on SAR data and how to model winter wheat and yield based on SAR data. And here we have a global distribution of test sites, and we are just one small test site in northern Germany, contributing our data to the global experiment. So how are we organized? So what we do, we organize field campaigns within a science network consisting of a scientific core team and a university network. The scientific core team is based on the GFZ, DLR, and some universities like Martin Luther University Halle, Würzburg, and Jena. And the university network is basically an open network that if universities are interested to benefit from our standardized concept, so that they can do field campaigns with their students, but with the help and our coordination of the core scientific network. So, for instance, we are doing student excursions and field courses with our EAGLE students in Würzburg, but also in Halle. Our partners are organizing field trips with the students there. So we have a general project management of like how to handle the data, keep the standards, but we also have a education component with the university network. And we realized four campaigns in 2018, covering the vegetation period of winter wheat between April and June, and 3 campaigns in this year. So a huge effort. And this is how to show you a little idea how our data flow is working. So we have here our sampling scheme with the subsampling units, and on each subsampling units we are measuring the vegetation parameters like height, and all the data are going into the DOI data publication, but also there's a link to the open data cube for the DEMMIN test site. So we have a link to the data publication, in-situ data publication, but also a link to the satellite data to just connect our in-situ data to analysis-ready satellite data. So the innovation of our concept is that we have a very innovative and effective data generation flow. So at first, precondition is we have a standardized field protocol, the so-called field reader. Then we have a digital data entry survey. We're just using tablets in the field. We have on-site preparation of the samples. So we have a field lab just 3 kilometers away from the plots, which is in collaboration of the local farming industry. We have a central data management system organized by our core team. We have a publication of the data with DOI, as mentioned. And we have online data access and planning, where our data can be accessed within the Terreno and DLR websites. And this is just giving you an idea how we practically work in the field. So basically our education program is linked with the data acquisition strategy. So our student groups, on the first day, they learn how to use it with our experts and senior scientists. And then this is showing you the second day, where the people are working very self-organized in small groups on the plots. As you see here, they're just capturing the biomass data for the biomass acquisition. And here they're just measuring soil moisture, and yeah, this is just giving you an idea how also what kind of effort it is to acquire meaningful and standardized in-situ data. Okay, but the basement of all this is to have a standard and a guideline, and this we provide, or we were just designing and optimizing that within a document called the field reader, which is basically documenting the whole process of acquiring soil moisture and vegetation parameters. Basically, it's a living document, and if you can optimize something to transfer knowledge on the devices, handling devices, how to handle the data, how to handle the samples, and later on the processing in the field lab. So we're just working on that. We also have tutorial videos, but this is a very important baseline document for all our activities. You have to imagine that different universities have to keep the standard, and therefore we need just a very good documentation of the whole process. It's not perfect, but it's the first beginning. If you're interested, just let us know. Anyone of the DEMMIN core team can help you out with further information. So to conclude, what are the key facts and the key learnings of our activities here? First, we need a strengthening of the collaboration of regional scientific networks between international activities. Like, we need really a strengthening between JCAM and the regional scientific networks. The whole experiment would not work without local and regional networks contributing data and insights, learnings on the in-situ level. Then we need incorporation of the farming sector and local users to create benefits of the farming sector and the science community. Vern would not be so successful in our 3 and 4 campaigns over the season without collaborating with the local farmers. On the other side, they expect a benefit from the EO perspective. So maybe they know that we can calibrate models exactly on their fields, and we are just providing them our soil moisture maps, for instance, to give you an example, that they can use that for daily, for their daily work. Then the definition of international standards for in-situ data is very important. So if, for instance, in JCAM, different regional networks are working together, and a standard how to assess data in the field is really important. And there's just a gap, there's a need for further collaboration and coordination of the international standard definition for agricultural monitoring, which is also in progress. And we need to focus. In general, focus is really important because we don't have time to get lost in specific facts like, for instance, we're just focusing on winter wheat. Imagine if you would introduce barley or maize, then we would have double work because we need a second in-situ data acquisition standard for a different crop type. So we don't have time and resources to do a little bit on many topics. We need to focus, and so we do that here. Just one crop type, which is winter wheat, and specific key biophysical parameters like soil moisture and vegetation and biomass. So data continuity is the general goal. Data continuity is given from the space component by providing us analysis-ready data from space. But what about continuity and analysis-ready data from the in-situ level? There's a lot of things to organize, to do, to make the data flow continuous on the in-situ level. So we're doing that by linking educational activities with project work on the network, but it's a very complex story, as you can imagine. And of course, fostering open data policy and publishing of in-situ data. So open data policy is a precondition that different communities, international communities, can work together. And we also put a focus on that. And yes, this is from my side. I think time is over, and I hope you enjoyed my talk. And if you have any questions, just don't hesitate to call us, write me an email, or anyone from the team. And we are happy to share our knowledge and insights and we are just open for further collaboration. Okay, thank you, and have a nice time here in Lisbon. Bye-bye.